A stone is thrown vertically upwards with an initial velocity of this. Neglecting a resistance, find the maximum height reached by the stone. B. The time taken to hit the ground. So before we draw the free body diagram, let us remind ourselves of the formulas that will apply in the y direction. So we have Vy is equal to Voy plus Ayt. The next one is y is equal to y naught plus Vy plus V naught y over 2 times t. The next one is y is equal to y naught plus V naught yt plus half Ayt squared, and the last one is Vy squared is equal to V naught y squared plus 2ay into y minus y naught, just like we did in the rectilinear motion in our last video. So we have these subscripts representing the y motion. So coming to our equation proper, let us draw the free body diagram. The stone is here, thrown vertically upward. Let's assume that it is increasing y direction and reaching the maximum height. At maximum height, the Vy, which is the final velocity, is equal to 0. Whereas acceleration due to gravity is acting downwards, so our Ay is equal to minus g. So it means that for the first part of this equation, that our equation will become V is equal to V naught minus gt. V is equal to V naught. We have dropped y. Ay is equal to minus g. Y is equal to V plus V naught over 2 times t. The next one is, let's do this one. We give us V squared is equal to V naught squared minus 2g into y. Let's assume that y naught is 0. And this one will now give us y is equal to V naught, this one is 0, V naught t minus half gt squared. So these are the equations that we will use to tackle this. So if we use this equation, we know that V is 0, Vy is 0 at the maximum height. So we have 0 is equal to this equation. 0 is equal to 7 squared minus 2 times 9.8 times y, and that will give us that this is 49. This one comes over here, we have y is equal to 49 over 2 times 9.8, and that is equal to 2.5 meters. So the maximum height reached is 2.5 meters. First of all, but before we do the time it will take to hit the ground, let us note that it will be obtained from here, from this equation. That is this equation. From that equation it will be time, therefore time to reach the maximum height, max height. Maximum height is T max is equal to V naught over G, V naught over G, V naught over G. So we'll keep it. Also, when the ball is at the maximum height, it is now falling freely downward. So it's now falling fully downward. So it means that we will now use this equation. Our AY is equal to G in this case, and the velocity is increasing downwards. So it means that we will use, if we use this equation, if we use, for instance, this equation, this one, if we use it, we'll have a V squared is equal to V naught squared plus 2gy plus 2gy. That's what we have. If we use this equation for time, if we use this one for time, we'll have y is equal to v naught t plus half gt squared. That's what we have. V naught is 0 because it's now considered that the maximum height and is coming down. The V naught is 0 there, so it's no longer final when it's going up. So we'll have that this one comes over here, it will be 2y over g will give us t to come down from that maximum height. So time to hit the ground, therefore time to hit the ground is equal to time t max plus this plus t. So it will be, our t max we got before is this. So if we put it, we will now have v naught over g plus 2y over g all square root. So we have it to be v naught is 7 over 9.8 plus square root of 2 times y is 2.5 all over 9.8. You see that we have 0.7143 plus 0.7143, which is equal to 1.4286 seconds. So, but the important thing is that you see that the time to reach the maximum height is also the time to come from maximum height to the ground, making it 2 times any1. You can say it's 2 times the time to reach the maximum height, or 2 times the time it falls from the maximum height. So that's how to solve this. Please subscribe. Bye.